Hello and welcome to class 12. Today is a review day, so I gave you some problems to work through that give you an overview of all the different things that we've been learning in this unit. So today I'm going to have a brief introduction and then I'm going to run through some answers to the problems. Class 13 is also a review day because it'll be the practice test. But the questions on the practice test will be much more like the questions on the actual test. In fact, sometimes they will be drawn randomly from the same pools of questions. Okay, but first let's just get an overview of the kinds of things that we've been looking at in the argument section of this course. So way back in class 2, I introduced the basic idea of an argument. And I taught you how to put it in standard form, right? You just list the premises, you draw a line, you write the conclusion. The main goal of this is to just help you keep track of what is premise and what is conclusion. In this section, I've been introducing specific kinds of arguments, and each one of those gives you a variation on standard form. So the kinds of arguments were argument by analogy, argument from authority, inductive generalization, and instantiation syllogism. And in each case, there's specific ways that you want to put the premises and a specific way you want to phrase the conclusion to bring out what makes this argument unique, right? Okay. Also, to evaluate arguments, we've got specific kinds of questions that you always want to be asking. Well, you've got questions you always want to be asking. There are general questions that just happen whenever you put an argument in standard form, which is whenever you have an argument. And then there are more specific variations on those for situations where are getting specific styles of argument. So the general critical questions are the premises true, or at least plausible? And if the premises were true, would they support the conclusion? And has any relevant information been omitted from the premises? Right? And so these are things you can always ask. And the important distinction that's being made here in the first two questions is the difference between the truth of the premises and the quality of the inference, right? So in the second question, you're being hypothetical. If the premises were true, what would they say about the conclusion? So for the different forms of more specific forms of argument, there are specific spin-offs or ways of variations on some of these questions. You can always be asking, are the premises true? But there are also specific ways you want to think about whether or not you know the premises support the conclusion, or specific kinds of missing information you want to look for. So for instance, with argument by analogy, if you want to know whether the premises support the conclusion, you need to think about the strength of the analogy. How many reference analogs? How diverse are the reference analogs? How many known similarities are there, and how relevant they are? There's also a specific kind of missing information that you want to look for. You want to look for relevant differences. And you have similar variations on the general questions for all of the other forms of argument that we looked at. So the first set of questions on the review sheet just deals with the general critical questions you would ask of any argument and the terms you use when you answer those questions, right? So we said that you ask question 2, if the premises were true, would they support the conclusion? If they provide perfect support, we say that the inference is valid. And then if we also know that the answer to question 1 is true, we say that the argument is sound, right? So we just want to generate some examples of different combinations of these words. And what I suggested you do is use simple categories that make it easy for you to generate examples. And so for me, I always just think about dogs and cats, and then some other terms around dogs and cats, mammals, animals, reptiles, pets, strays. Um, and the idea is to generate sample examples of true statements. For instance, 98% of dogs are vaccinated for rabies. And false statements, like 75% of dogs are reptiles. And it helps to talk about individuals. So I gave you my example of an individual. This is my dog, Cupcake. Cupcake is a dog. That's a true statement. Students filled in often their own examples with their own pets, which I thought was actually quite cute. All right, so let's look here. The first thing I asked for was an example of an argument that was valid but not sound. So to construct this example, you need to have an argument that has the form of a valid argument, but has a false premise. So if the premises were true, they would support the conclusion, but in fact, the premises are not true. So remember our standard example of an argument that is both valid and sound. All people are mortal. Socrates is a person. Therefore, Socrates is mortal. What you can do here is take that example and substitute in a false statement for the first premise. And we can just create that variation using the sample ideas, the terms that I listed. So all dogs are reptiles. It's a false statement. And then we say Cupcake is a dog, therefore Cupcake is a reptile. That is an argument that is valid but not sound. So the next thing you want is an example of an argument that is strong but not cogent. And the thing to remember here is that this is just like the previous question, except instead of using the form of a deductively valid argument, you want to use the form of an inductively strong argument. So rather than trying to find an argument where the premises, if they were true, would make the conclusion certain, you're only looking for an argument where if the premises were true, they would make the conclusion likely. So actually, let's just start with an example, the standard example of a strong argument, in fact, a cogent argument from the homework. This is the very first homework assignment where we talked about strong arguments. There are tracks in the mud. Tracks like these are made by bears in almost every case. Therefore, bears have been down by the river. We were just imagining like a park ranger giving this argument. So what we want to do, this time where we're going to use P2, we want to replace P2 with a false statement and then reconstruct the argument using the terms and categories that we were given already. So Cupcake is a dog, which is true. 75% of dogs are reptiles, false. Cupcake is a reptile, false. So that's an argument that's strong. If the premises were true, you could be 75% confident in the conclusion, but it's not cogent because the premises aren't true. So here are a couple examples given from the class. 98% of dogs are Cupcake. Spot is a dog, therefore Spot is Cupcake. 95% of clownfish are funny. Nemo is a clownfish. Nemo is funny. So both of those premises are false. But if they were true, you would be 98% or 95% certain of the conclusion. So these are strong arguments that are not cogent. Next up was an example of an argument that was both valid and sound. The easiest thing to do here is just stick with the terminology that we've always been using, the terminology that's been given in this problem, and problems that and argument forms that are like the ones we've always been using. So all dogs are mammals. Loki is a dog. This was an example that came up in class. Someone gave their dog. Therefore, Loki is a mammal. Right? And this has the exact same form of the standard argument that we've been using as an example of an argument that is both valid and sound, all people are mortal. Socrates is a person, therefore Socrates is mortal. The last thing you needed was an argument that is weak. And so this is easier because it just doesn't meet any of the evaluative standards that we've named so far. So an example from the class: most reptiles are red. Grass is red, therefore grass is a reptile. It's got false statements, but more importantly, if just because two things are the same color doesn't mean that they're the same. So it's just a obviously bad argument, right? Okay, the next set of problems deals with specifically with arguments by analogy. And the first set of questions ask you to distinguish passages where an argument by analogy is being given from passages where there is an analogy, but it's being used for some other purpose, right? So the first example is a quote from the philosopher Friedrich von Schlegel: publishing is to thinking as the maternity ward is to the first kiss. The thing to see here is that there's a comparison, but actually there are no known or inferred similarities being specified, neither known nor inferred. You can kind of fill them in, but in no way would you wind up getting something where you're trying to infer some similarities from others. So really, this is just an argument. This is just an analogy used for illustration. Next question. Historically, the market goes up when the employment situation worsens and goes down when it gets better. Right now, there is bad news on employment. This could be a good time to buy stocks. This clearly looks like an argument, right? The speaker is trying to convince you to buy stocks. So it's an argument. We just need to figure out what are the parts of the analogy. And the thing to see here is that this is an analogy between the past and the present. This is one of the biggest ways we draw lessons from history, right? History doesn't repeat itself. It just provides analogies for the present. So what we want to say is that the reference analog is historical situations where employment was bad and the market was good, right? And then the target analog is the current situation. So it would look like this. The current bad employment situation is likely to be similar to past bad employment situations. In the past, stock markets have gone up. When there's bad employment, it's a good time to buy stocks. So premise 1 establishes the comparison. Premise 2 asserts the inferred similarity for the reference analog, and the conclusion asserts the inferred similarity for the target analog. Yamaha makes great motorcycles. I bet their pianos are pretty good too. This is also clearly an argument saying, I bet that. These kind of indicate an inference. Someone's drawing a tentative conclusion. We actually don't have any known similarities specified, but we can kind of fill them in. We can just say that these are both things made by Yamaha, right? So pianos made by Yamaha are like motorcycles made by Yamaha in that they're both made by Yamaha. Yamaha motorcycles are good, therefore Yamaha pianos are good. The last one, life is like a roll of toilet paper. The closer you get to the end, the faster it goes. This is not an argument. This is more like an unfunny joke. A student suggested that this was an argument with the conclusion that time feels faster when you are old. But why would you use a comparison to toilet paper to make someone believe that time seems faster when you're old? You just have one similarity specified that's kind of metaphorical, actually. It's a joke. Okay. The next problems ask you to do the full analysis for a single argument by analogy. The passage has you looking at casinos, and it says that casinos in 3 locations all brought in revenue without encouraging crime. Therefore, we infer that a casino in Buffalo will do the same thing. Again, this is an argument by analogy, using past situations as an analogy for the current situation. So the reference analogs are the casinos that already exist. The target analog is this proposed casino in Buffalo. The known similarities aren't specified, but we can fill them in. These are all legal, regulated casinos in similar states and provinces. The inferred similarity is specified. They provide revenue without encouraging organized crime. So we want that in the conclusion. We just take these parts now and fill them in for our argumentation scheme for argument by analogy. Premise 1 asserts that the current casino is similar to the past casinos. And we can fill in the known similarity, even though that was only implicit. We can just fill it in and say that they're all legal, regulated casinos. We say that the inferred similarity is true of the reference analogs. The other casinos have brought income without encouraging organized crime. Therefore, the Buffalo casino will bring revenue without encouraging organized crime. And last up, we want to use our standard questions to evaluate the argument. And if there's missing information, say what information you might need. So there are 3 reference analogs, and they're pretty diverse. They're all in separate states or provinces. The number of similarities there were no listed similarities, but it was easy to come up with implicit ones that were relevant, right? And looked good. The only information we don't have is whether there are any possible differences, and so this is something we would need to fill in. But overall, I would say that this argument is quite strong. So next up is an argument by authority, and then I've got 3 questions you need to answer about that. So we're imagining some guy, Brad, he's trying to understand a scientific issue. He thinks, oh, well, Ben Stein, speechwriter for Richard Nixon, host of a game show that tested people's knowledge on obscure topics, and an actor famous for playing a teacher in Ferris Bueller's Day Off. Ben Stein has a movie out called Expelled, where he claims that there's no scientific basis for the theory of evolution. Stein's a smart man, Brad thinks, and unlike professional biologists, he's not biased by his training into thinking evolution is true. So because Ben Stein says evolution is unscientific, I conclude that evolution is not true. This is clearly an argument by authority. We've got the because and the I conclude that. And the because is a statement about what someone else said. Ben Stein says it, so it must be true. Well, when we put it in standard form, the way I did it here, I just went ahead and based it on the actual statements in the passage, including Ben Stein is a very smart man, Ben Stein is not biased, and then Ben Stein says evolution is unscientific, therefore evolution is not true. And it's really that last premise and the conclusion that most closely mirror the form of the argument from authority. Someone says something, therefore what he says is true. And actually, the speaker here is making a bit of a jump between saying it's unscientific and saying it's not true. I mean, those are technically different things, but um, if you're thinking the way this guy Brad is, you're gonna make that kind of jump. All right. So now evaluate the argument. We've got two questions here. Is the speaker in a position to know? And is the speaker biased? Oh, and also is the speaker backed up by other experts in the field? So is the speaker in a position to know? Not really. I mean, Ben Stein, he's not, you don't hear about him so much anymore, but for a while he was famous and had the reputation for being a smart person, but it was really just because he played a smart person on TV, sort of the way that some politicians play businessmen on TV. Right? So none of his credentials are scientific. The argument actually claims that scientific credentials make you biased. But, I mean, if that were true, then no science would be reliable. And I'm certain that the people who make this kind of argument rely on science all the time, right? Scientific credentials don't make you biased. They introduce you to the evidence for a proposition. So is Ben Stein biased? Well, he's an activist with an opinion, but merely having an opinion doesn't make you biased, right? Any more than having scientific training makes you biased. This is a problem I see often when people are discussing bias. Sometimes people say that the only unbiased thing to do is have no opinion. That doesn't make any sense. You want to be generating actual opinions by considering the evidence fairly. So you can't just run around calling someone biased because they have an opinion based on evidence that they've seen. So I guess the one critical question that I'm missing here is the speaker backed by other experts? And of course, he's not. Nothing, nothing in biology makes any sense without the framework of a theory of evolution right now. So all biologists believe in evolution. Next up is a multiple choice question. This one's a little bit tricky. So I said, suppose someone responds to this argument by saying, despite his reputation, Ben Stein is not actually very bright. A lot of people here are going to be tempted to say, D, this is an irrelevant ad hominem attack. Especially in some forms of it, I say Ben Stein is actually quite stupid. And when I phrase it that way, everyone's immediately drawn to answer B. Oh, that's an ad hominem attack. But really what's going on here is that because we have an argument from authority, things are already personal, right? We're supposed to believe something on Ben Stein's say-so. So saying that he's not very bright is just saying that he's not a reliable authority. It's a challenge to the truth of one of the premises. Specifically, it's a challenge to the premise Ben Stein is a very smart man. Okay, the final two questions go together. They've got the same instructions. And the main thing here is you need to decide for each one whether it's an inductive generalization or an instantiation syllogism. And again, the way to tell the difference between these is to look for the big general statement. If the big general statement is in the conclusion, the argument is a generalization because you are generalizing to that big general statement. If the big general statement is in the premises, then it's instantiation syllogism because you're reasoning from a big generalization to something about a particular. And then once you decide whether it's an inductive generalization or instantiation syllogism, you need to analyze it using the appropriate tools. So the first question, the first sample passage is about Charlie and the Chocolate Factory, the children's book and several movies that are widely loved, but actually kind of weird and problematic. But in any case, we imagine Willy Wonka is considering what benefits he should offer his workers, and he says 18 out of the 20 Oompa Loompas I rescued from Oompa Loompa Land have had post-traumatic stress disorder from their encounters with vermicious knids. I bet 90% of the millions of Oompa Loompas in Oompa Loompa Land have PTSD. I should really offer psychological counseling to my employees. All right. So let's make this a general argument. Well, I'll just put the whole thing on the screen here. So this is an inductive generalization. You can tell because after he says, I bet, and gives his conclusion, he is making a big claim about all the millions of Oompa Loompas in Oompa Loompa Land, right? So it's a generalization. The generalization, we can identify the standard parts of a quantified categorical statement for it. It's 90% is the quantifier. The two properties are being an Oompa Loompa and having PTSD. And so the way I've spelled it out here, I do it with two premises. 98%, 20 new hires are Oompa Loompas, 18 of them have PTSD. Those are both statements about a sample that amounts to saying that 90% of the sample has a certain property. And therefore, you conclude that 90% of the population, the whole population of Oompa Loompas everywhere has PTSD. So I know this is a made-up example about a children's book, but it should be clear that the arguments is weak. The basic questions we're supposed to ask here is whether the sample is large and whether the sample is representative. We know a sample of 20 for a population of millions is not large enough. Also, the sample is not representative because the sample was not taken randomly. Whatever method Wonka has for rescuing and employing Oompa Loompas, or perhaps kidnapping and enslaving them, probably do not give him a random sample. So the argument is weak, and here's a picture of a traumatized Oompa Loompa. All right, last up. A field biologist is observing a herd of elephants. Here, let me do this over here. Actually, that doesn't work. Okay, so most wild elephants live to be about 50 to 70. We now know that the matriarch of this herd is at least 60, because scientists have been following her that long, so I don't think we can expect her to live more than 5 to 10 years. That first sentence should be in italics, which is the way it appears here. Let's get this all in. So this is how it all looks. So this is an instantiation syllogism. The big generalization is in the premises. Most wild elephants live to be about 50 to 70 years old. Big generalization about wild elephants. The conclusion is about a specific elephant, the matriarch of this herd that they're following. Elephants are matriarchal. They're led by the eldest female. So our quantifier is most. Our property F is being a wild elephant, and G is living to 50 to 70 years old. Premises. We know that most wild elephants live to be 50 or 70 years old. We know that the matriarch of this whole herd is at least 60 years old. Conclusion, we can expect her to live 5 to 10 more years. After, I'm certain, a life of proud leadership and service to her herd. Well, to evaluate this argument, we only need to ask one question. Is this a typical case? Is this a normal elephant? And since this is a made-up example, we can just assume that it's true, and therefore the argument is strong. Okay, so those are examples of all the kinds of things that you need to look at, kinds of arguments you need to know for this section. And then next up, we've got the practice test, where we'll put all these questions specifically in the kinds of forms that they will be in on the test.